Record. Where is it recording? Okay, it's recording. Give me a second. Okay, guys, today's class will end again like every 40 minutes. I need to somehow figure out a way to get us unlimited class time, or we might switch platforms to go to meeting.
I like that.
No. Yeah.
Super.
Okay. I just have to rejoin the same link. But what's the time? Okay. It's
Okay,
we should probably start now. Just let me connect this, and then we'll be ready.
Isn't he speaking?
No, I'm not saying anything.
Nice.
Right. Guys, next class I was thinking we'll do a little bit beyond the Arduino and everything, and I'll talk about a few other rather interesting science concepts. I'll talk to you all about how touchscreens work and capacitive touch and all of that. I think that'll be interesting, isn't it? Something like that. So if you have any like burning technology related questions or things that we can discuss, just let me know, and we can actually have like a fun discussion about it right before we jump into the class. Okay, and I'm going to start now, and I'm going to mute everyone as well. Give me a second. We are ready. Got people in. Yeah, I'd say it's towards a generally wrap up in an hour and a half. And what else do we have to do? Yep, mute everyone. You cannot unmute and right. Okay, I think we're ready to start. Good evening, everyone. Glad to see a few of you all here. About an hour and a half. If you guys get tired, let me know. I might end it a little bit early. I mean, today I don't have like a set presentation we're going to be following, but it's going to be more of more of us making circuits and learning along the way. All right. And we do not need audio on the second one. Give me a second to stop it. Okay. So let's get started. Now I'm not going to waste time introducing myself because literally everyone here has been in at least one class before, so they probably already know. But anyways, you guys know I conduct a lot of workshops, and that is basically why I'm taking these classes for you all to learn STEAM and everything related to it, even while you're at home. And I cannot go ahead without a necessary plug for Makers in the Oasis, which is a Facebook community for you all to learn from each other and basically, share what you've been working on and yeah, stuff like that. Basically, oh wow, Omar is here, and basically, if you aren't already a part of the community, please join and let's help each other learn more. Okay. And I'm switching off the chat. Okay, so this is basically today's lineup. We're going to do a recap. We're going to do a pretty long recap because was everyone here there for the Arduino class last week? 1 second. Yeah, no, Vedant, you weren't? Okay, if you all were there or weren't there, irrespective of that, I expect you all to, if you all were there, basically answer. If not, I'm going to talk briefly about what we covered in the last class. So no worries, Vedant, just follow along. So recap, it's going to be pretty long. After that, we're going to learn how to turn on an LED using an Arduino. Then we're going to learn how to blink an LED using an Arduino. Then how do we use a switch with an Arduino, and finally using an LED and a switch with the Arduino. So there's going to be a little bit of drag and drop block-based programming that we're going to do, not text yet, but we're going to slowly graduate to that. We're going to talk about another special type of sensor. We're going to talk about ultrasonic sensors. And today's class is going to be pretty much about these things. We're going to be using the Arduino and learning how to do that, right? And yeah, using Scratch-based block programming. Okay, so what is this called? Toggle switch. It's like you guys saw the image, so you all had like the answer ready. That's okay. Okay, next. What is this? Guys, what's this called? Potentiometer, right? And what is it? Right, Omar. And what is a potentiometer also called? Variable resistor. That's right, Razak. Okay. Glad to see you're paying attention. No, it is used in a voltage dividing circuit, but it is not a voltage divider itself. Actually, it can be used as a voltage divider. I'll give you all that. But I haven't really explained how you can use it as a voltage divider. Unless I have, I don't think so. So, yes. Okay, what's this? See, if you talk about potentiometers, you have to talk about servo motors because they're the only motors with like a closed loop system where for every degree it moves, it has a potentiometer to tell it how much it has moved inside of the motor and then change its motion according to that as well. So it's like a closed loop system. It's responsive. You can tell them exactly how much to move, and they have a lot of gears so they can lift a lot of weight. Like I've got these massive servo motors that I'd use in my humanoid arms that could lift like 60 kgs per centimeter. Like they had 60 kg per centimeter torque. So they were massive. They're like this big and like they draw a lot of power, but they could lift 60 kgs. So like that's more than the weight of a few of us. Next, what's this? Yeah, they were very, 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 very heavy motors. Nope, it's not a buzzer, Razak. It's a speaker. Farhan's right. And then Jatin and Dhruv. Let's do this, guys. How about we do something like, let's use the first one to answer and then he'll get some sort of a prize. I'll let him control my computer and make a circuit, something like that. I don't know. We'll figure out the prize. But for the next question, you guys have to tell me, answer this. And don't send the answer to me privately. I'll give you a second to change that. I want everyone to to send in the answers to everyone so everyone knows that who I'm giving the prize to is fair. So what do you think is this? Monkey see, monkey do, monkey repeat, isn't it? Jatin's the only one who got it right. Jatin, guys, seriously, how does this look like a diode to you all? What are you all talking about? I think it was Farhan who put in diode and everyone else just copied him. Very nice. Now let me show you all a diode because I have no idea how did you all confuse that for a diode. Yeah, what is this then? It's okay, Farhan, we're all learning. Guys, what's this? Exactly. So that's what a diode looks like. Yeah, not this. So who was it who answered first? I announced his name. Great. No, I forgot. Nope. Jatin. Yeah. So Jatin came in first in this one. Yeah, it's a one-way road for electricity. Okay? What's the next one? Watch sharing for a second. You know what? Okay. Excuse me. Yeah, Jatin, what do you want as a prize? Okay, you don't want it. Nice. What's this? Wow, Jatin comes first again. What sensor, Farhan? Sorry, Jatin's first. Okay, next one. Okay, everyone's ready. If there is anything next, I don't remember at this point. Anyways, let me explain. Everyone knows what this does, right? Anyone who doesn't? Because I will explain it. Okay. For those all who you weren't there, LDR is basically a variable resistor. It's a variable resistor that changes its resistance based on the light that's incident on it. So when a lot of light is incident on it, then it lets a lot of electricity through. And there is very little light incident on it, it has high resistance. It does not let a lot of light through. Okay. Give me a second. Moving on. What's this? It's okay. No one knows. And we use an LDR in a voltage dividing circuit. I'll talk a little bit about voltage dividing circuit when we're working with the Arduino. Again, though I'm pretty sure everyone knows. Okay, what do you all think? And this is not a quiz because I don't expect you all to know it. What do you all think an ultrasonic sensor does? Take your guesses. Yes, Dhruv. Nope, it does not sense reflected light. Dhruv is right. It detects distance. And let me just give me a second to look for mine. All right. Okay. So this is basically what an ultrasonic sensor looks like. You get these pretty cheap. I think like 7, 8, 9, 10, 10, something like that. So an ultrasonic sensor, it does not do anything. It uses sound waves, but it does not affect the sound. It does not make it louder or something. It's not a speaker. But in essence, you guys are right. It does measure distance and it uses sound to do so. What does it do exactly? I'll tell you all now. Okay. So a basic ultrasonic sensor has 3 parts. That is 2 transducers and 1 controlling circuitry. Now, what does a transducer do? Now, there's one transducer which is the trigger and the other one which is the echo. Wait, before that, you'll see the 4 pins here. Now, this is going to be a standard for pretty much any sensor that you all use. I'll tell you all. Wait, I'll tell you all. Now, this is going to be a standard for pretty much any sensor you all ever use. Whenever it says VCC, it means it needs to be connected to 5 volts. Okay. So do you all remember on the Arduino, there was a 5 volt pin? For those who weren't the last class, I'll talk about it again. But for those who were, you'll remember the Arduino had no, not the win pin, a 5 volt pin. Yeah. So the VCC always gets connected to the 5 volt pin. Okay. Then what do you think the ground gets connected to? In the power pins. Yes, Jatin, it's in the power pins. So out of all the power pins, and I'll talk about this again in a while, there is a 5 volt pin. So the VCC for any sensor needs to be given 5 volts. Okay. So you connect that to the positive of a battery. Like if you think of it as a battery, the VCC is connected to the positive of a battery. And negative of the battery is connected to ground. That's right. So we're going to get these 2 out of the way. This is connected to negative, VCC connected to positive. So like if this is a battery, this is how you're connected. There, positive and negative. Done. Next is trig and echo. Here's when an Arduino comes in. Okay. So what the Arduino does is it generates this special kind of a wave. Yeah, I will. Wait. Right. So it generates a special kind of a wave that it gives to the trigger pin that basically, guys, give me a second. My stylus is not working. I can't teach without it. Give me a second. Wow, this sucks. And I've got a lot of this. Never mind. This is not working. I'm just teaching with my hand today. So basically the trigger pin and is where an Arduino comes in, and the Arduino gives it a special signal, okay, that makes one of the transducers give out a special kind of ultrasound. So it's the human hearing frequency, we can only hear up to like 20,000 hertz, right? Like a bat. Yeah, you can. Yeah, exactly. With ultrasonic sensors, basically like a bat. You know how the bats, they cannot see. So what they do is they make a sound and then they measure the distance that it takes for the sound to come back. This is literally what an ultrasonic sensor does. So the Arduino gives the trigger pin a special kind of signal. So it triggers a special kind of sound wave out of the transducer. Okay, and then it bounces off the object. Whatever, if there is an object in front of the sensor, it's going to bounce off the object and it's going to be heard by the receiving pin, the echo pin. You know, when you shout, at like a wall that's at its greater than 17.5, I think it's something like that. I don't remember exactly. 1.75 meters. Yes, something like that. Then the voice echoes and comes back to you. Oh wait, forgot to turn on the annotation thing. Yeah. So do you all know that? Like, you all know how echo works, right? There is a sound, it bounces off an object and it comes back to you, right? Okay. So basically, the transducer gets one of the trigger pin gets one of the transducers to give out an ultrasound that humans cannot hear. Then the ultrasound bounces off the object and is received by the echo pin. Okay, that the Arduino can measure. So the Arduino comes to know when the echo pin can hear that sound. And then what happens is basically it calculates the amount of time it took for the sound to get from the trigger pin to the object and back. Okay, and then wow, I really need my stylus. If you all can be patient for like 1 second, I can explain this better. Not using what I can do. This won't work. Okay, I give up. Okay, so basically, think of it like this. There's a blank slide next. Yeah. So the ultrasonic sensor is going to be here. Sure, Omar. Thank you. They're going to be, this is the ultrasonic sensor here, and the trigger pin is going to emit the sound. So if there's an object over here, let's draw that here. The sound is going to bounce off the object, and it's going to come back and going to be received by the echo pin. Okay, and then it's going to calculate the distance, the time, and divide the time by half. You understand why it divides the time by half? Because if it takes like like 10 seconds for between the trigger pin making the sound and the echo pin receiving it, then half of that is the amount of time it took to go one way, right? And if you're if you're a little bit young, then probably in your in the cars you'll have seen that speed is equals to distance by time, like kilometer per hour, right? 1 second. Yeah, so you know speed is kilometer per hour, right? So basically, if you know the time and you know the speed of sound, because speed of sound in a particular medium is constant, right? So if you know these two, then you can calculate the distance. Yeah, meter per second, it's kilometer per hour, same thing. Just convert them by 18 and like so the thing basically multiplies the speed with the time it took to get the distance, and that's basically what the ultrasonic sensor does to measure the distance between an object in front of it. Although there are a lot of limitations to this. For example, if the wall is like this and it's approaching the corner of a room, this thing gives out the sound and it's given out in this direction. So the readings can be inaccurate. That's why it works most of the time, but sometimes it doesn't. So we just have to be careful about those times, perhaps. What do you mean another time? Oh, okay. Right. Okay. You mean the limitation of it? Yeah, yeah. So like, think of it like this. The sensor is here. Wow, clear. Yeah, I get it. Sensor is here. It's on a robot. Okay, so this is for the robot to know when an object is coming close to it. Okay, we've put an ultrasonic sensor on a robot to find out when it's approaching an object. Now, what happens is, what if the robot is walking towards a corner? That's like this. Okay, what if it's going towards a corner? Then the sound from this side is going to bounce off this edge and going to get reflected that way. Guys, yes or no? Why do you say it's in? Okay, that's why the readings will be inaccurate, because it's going to get reflected in that direction. So nothing's going to come back to the echo pin. Yeah, basically, like, cars have reverse sensors, the sensors behind the car to tell you when you're about to hit something behind them. While you're going reverse, you go like beep, beep, stuff like that. So basically, this is what the sensors do. They give out a sound wave and they detect when it comes back to them. Okay. Omar, if you do not have anything that's relevant to our class, kindly do not use the chat. Okay. Because I just feel it. Yeah, it does that continuously. The Arduino controls that. Okay, so now tell me this. What is this? That's right. It's a microcontroller. How does this look like a buzzer to you, Danaj? Right. Yes, it's a microcontroller. And do you guys remember any of the limitations of a microcontroller? Why are microcontrollers difficult to use, like directly without an Arduino? Anyone remember that? Okay, you can say very small is a limitation. What else? Yeah, it is basically the brain of the Arduino. It cannot run without that. Tell me, limitations. Okay, does anyone remember that microcontrollers directly are difficult to program? You need to know like hex commands for them. That special kind of encoding, which is not easy to, basically you have to program it in bytes, like ones and zeros and stuff like that, and like there's special registry and all that for it that you'll have to remember, so it's not easy. Then there was a special type of connector that you needed to program microcontrollers, and there was going to be too much circuitry for you to program them. Basically, you remember all that? Yes or no? And what did the Arduino do then? The Arduino board basically took all of those problems and solved them by making one board that makes it super simple to program the microcontroller by putting all the necessary circuitry on the board, including protection circuits, including all of that. Then they made a programming language on an integrated development environment on an Arduino IDE. Yeah, on an Arduino IDE for you to program the microcontroller in simple text. Literally, the Arduino's IDE is like a variation of C#. It is the second most easiest programming language that you can think of after Python. And we're going to be using blocks to program Arduino today. And then we'll come to actual code-based programming next. So this is all the extra circuitry that you need to program a microcontroller and stuff like that. And Arduino took away all of that. There are hundreds of kind of Arduino boards, like we said, but the most common one that we'll be using for our course that's available online is the Arduino Uno. That's right, Razak. And an Arduino Uno basically has okay, we come to the pins. They once is enough. An Arduino Uno basically, we'll go into the specifications, but as we change the kind of boards, the functionalities and the kind of things that they can do also changes. Okay, so like for example, like in Mega has more number of sensors that you can connect it to. Then there is an Arduino IoT board that you can connect to the internet and stuff like that. Zoha, if you have a question, you can ask me. Do you have something you want to know? Yeah, it's Arduino, because it has a microcontroller, can serve as a brain in many projects. Okay. Yeah. Next. So now coming to the pins that we have on the Arduino. These are basically first two important pins, TX and RX. So when you connect the USB cable to it, The USB cable is basically connected to these two pins that is used to program the Arduino. Firstly, it can talk directly to the microcontroller. Secondly, the TX and RX pins allow you to basically talk in serial communication. So like with all the other pins, you're basically dealing with electricity by turning electricity on and off. But the TX and RX pins can receive and give out text data in the form of text. So like, for like my prosthetic arm project, I had a Bluetooth module. And okay, so I had a Bluetooth module, and the Bluetooth module basically through voice commands would give text messages to the Arduino. So in such a case, I had used the TX and RX pins for it to directly talk to it. Excuse me. Right. Next up is the digital input and output pins. So the input and output pins, there are 13 of them, 14 of them are the Arduino. The TX and RX pins also serve as digital input and output pins. And what the digital input and output pins can do is, you can think of them as mini power switches. Okay. So in your program, you can choose when to give them power and when not to. So when a certain condition is reached, and we will see this in a while, you can tell the pin to become high. And when you say become high, it means like connect it to like 5-volt power basically to power a small electronic device. And when you're done, to pull it low. So that's the output bit of it. Then these digital pins can also be used as input devices, where based on the number of volts they're receiving, like a voltmeter. Farhan, I'll tell you. Now, based on the number of volts that they are receiving, they can basically be used to receive data from a sensor. Okay, and it can be different kinds of data because it's digital input. Means some sensors, for example, the PIR sensor gives out a 1 or a 0 based on when it is turned on. So the digital pins can directly read that as a 1 and a 0. Okay. Now you all might be wondering, like Farhan very rightfully asked, what is the wave thing next to 6 of the pins? So this thing is, there's 6 special pins out of the digital pins that have PWM capability. PWM stands for pulse width modulation. So pulse width modulation, I'm writing with my finger, that's the best handwriting you're going to get. Pulse width modulation is something that is used to control motors. Okay, and when we talk about controlling motors, basically there's a special kind of wave that we need to generate to control the speed of the motor. Okay, and I'll talk more in detail about that a little bit later when we actually go and try a motor. But that's basically what they're used for, because that sign just indicates that those spins are capable of generating that special waveform. Does that make sense? Drew, I'm using Zoom itself, just on an iPad. Okay, next. Are you guys following everything basically? Understanding everything? Yeah, and these are analog pins. How many analog pins are on the Arduino? Yep. And what do the analog pins serve like? Can anyone actually, turn on their microphone and explain it to everyone? Guys, like, don't be shy. They're like 18 people. So, anyone willing? Dave, you'll explain? Okay, wait. 1 second. Let me unmute you. Okay, Dave. Go ahead, tell us. You're unmuted. Hello. Where is he? Dave.
Is it teacher only told? He's 17 and he's
Okay. Dave, are you going to explain or should I just explain? Never mind.
they're like They are also like the pins above.
Hmm.
Like I have just learned basics. So they are like the pins above near the ground, that will be the negative, and the pins there would have one volts one,
Hmm.
and it's like the above pins only.
Okay. That's like
Connect.
that's it's somewhat correct, but it's not entirely correct. Okay, and I'll explain this to you properly because this is not a 5-day course; it's a longer course where you'll learn better.
Relearn के लिए कर
Okay, wait.
कटलो कलता
Side
आ
background.
मैं कासुगर बरता थी
Okay. Okay. One second. One second. Okay, everyone's muted again. Okay, that's okay. But there, your explanation was pretty much correct. You're right about where they're positioned. They're positioned below the ground pin. And what Razak said is actually more accurate. They're like the positive of the voltmeter, and they're used to. Oh, Jatin, you want to say something? Okay, if I can unmute you without unmuting everyone, I will do it, or else we have to move on because it takes time. Jatin, unmute. Okay, Jatin, what do you want to say?
So like analog pins, there are 6 analog pins. It is basically the positive of a voltmeter. Can measure voltage. They can take the voltage reading from 0 to 5 volts. And as they're taking the reading, they use a mathematical formula to convert that value to something between like 1 to 1023.
That's absolutely right. And I think that's what Razak said as well. So both of you are absolutely correct because that's literally what it does. Okay, there are 6 analog pins. They're like the positive of a voltmeter, and they take readings from 0 to 1023, and they assign a value between. That's good. And they assign a value between 0 and 1023 based on how many volts it is. And we're going to try all of that right now. So yeah, let's actually go and try it rather than me just talk about it. Okay, and that's why when it says activity time, because it is. Wow. Okay, I wanted to talk about the power pins before we go ahead, and I took away all images of the power pins. That's the quiz. Nope, no relay. Next class we'll be discussing relays, but until then, I mean, if y'all want, y'all can do the same thing while I'm doing it. Just look at this image. I'm going to talk about. Really quickly going to mention the power pins. Okay, so these pins at the bottom, um, these pins at the bottom are your power pins. Okay, and the win pin can be used as a power input, voltage input win, and it can take between 0 to 20 volts. Okay, anything between 0 to 20 volts. The ground acts like the negative for the entire board, so whatever you're connecting has to be connected to ground, or else nothing works basically unless it's connected to ground. Nothing is accurate, nothing works. Then we have the 5-volt pin, which is like the positive of a battery, of a 5-volt battery. There's a 3.3-volt pin, which is the positive of a 3.3-volt battery. And these are all regulated, so like yeah, it does not change. And then we have reset pin, which is used to reset the program wherever you are. Okay, now I'm going to start Tinkercad, and we are going to make circuits because that's fun. We've done enough of boring theory nonsense. Let's actually go and experiment everything, and let's put some solid ground on what I've been telling you all this while. And I'm switching off my annotation thing. One second. Right, I've got my computer. Tinkercad is on. I sign in. And see, guys, I don't expect myself to go into like the depths of no, okay, so when unless you'll have the physical board, you all will not be using the reset button, because in Tinkercad you just stop the simulation and restart it. So what after the circuit is done? What do you mean, Jatin? No, we're not doing one circuit. I'm going to do like 2 or 3 circuits. If you all want, you all can follow along. You all can do this after the class. Take screenshots right now. That's up to you. Okay. And give me a second to pin my video. Yeah. Circuits. Let's create a new circuit. Okay, you know what? Before we do that, let me quickly show the ultrasonic sensor. This is not including all the spam and all of that. This is just the important ones. No, 20 minutes are not remaining. It's more than that, I'm guessing. Okay, quickly showing this to you all. These are just 649 minutes. Irrelevant. Coming back to this. So like I said, an ultrasonic sensor can measure distance. I'm going to start the simulation and just see what it does. In real life, it's much cooler. This is kind of lame, but this is the only thing that we got. Okay, see, this is an object. As it comes close, the sensor can know. Why? Because there's sound waves coming out of it from there, bouncing off the object and coming back. Okay. All right. So that's basically how this works. This is a little bit different because it only has one signal pin. Normal ultrasonic sensors do not work like that. Normal ultrasonic sensors are more like they are 4-pin ultrasonic sensors, like that. So there's a trigger pin, there's an echo pin, and there's a ground pin. Okay, but mostly no sensors in today's class except for a switch. Okay, let's get out of here. Okay. What do you want to say, Dev? Do you want me to unmute you? It depends on the ultrasonic sensors. So different brands have different ranges and depends on that. Okay. Now let's go back to this circuit. I'll come to that, Jatin. Wait, we'll do sensors properly. I just wanted to show this to you. Right. And okay, so we're gonna get the Arduino in. Get an Arduino, and I'm gonna get a voltmeter so we can experiment. Okay, a voltage meter. All right. So basically, like I told you all, the 5 volts act like a continuous source of 5 volts. So I connect that to this, and I connect the ground to that. So it's red, and this is black because right, I want it to look half as decent. Okay, and then I start simulation. You see, the pin reads exactly 5 volts because that is what it's intended to do. It's a continuous source of 5 volts, like the positive of a battery. Next, I'm going to disconnect this from here, put it in the 3.3 volts. Oh, wait. And okay. See, 3.3 volts exactly. Because you connected the positive to 3.3 volts and the negative to ground. Very basic. This is just me showing you all how these things work. Okay. Next, we're going to do this. We're going to experiment with the analog pins because they come in next. So I'm going to take a power supply. I'm going to connect the positive to one of the analog pins because it's the positive of the voltmeter, and I'm going to connect the negative to ground. Okay, then I have to do some basic Arduino programming to basically get a reading from the analog pin. This color will be red and this one will be black. Okay, now we're going to code it. Nope, we're not using any of this. Cool animation. And so we're taking the input from, okay, so when you come into blocks, this is where the block based programming happens. You go into input because we want to read the sensor pin, right? Analog pin is a sensor. So we're taking an input. As you're taking an input, you come under input section and you click on read analog pin A0 because we're taking a reading from the analog pin A0. Then, okay, so when you're dealing with the Arduino, you remember I said there's something called serial data, which is like actual text data. So now if there is data called serial data, there has to be somewhere where we can see that serial data, right? That's used for serial communication. That is called the serial monitor. So when you want to see what data the Arduino is receiving on a certain pin, you use something called the serial monitor. So the basically very simple code is going to be print to serial monitor, read unlock whatever reading it's getting on the sensor. I'm going to start the simulation, and 1 second. What's that, Mohammed? Can you all hear me clearly, or do I have to speak louder? One second, there's a thing with the code compiling thing. I have no idea how to deal with that, to be honest. Yeah, okay. So we're gonna open code again, and we're gonna open our serial monitor. Okay, do you all see this? See the value you're getting on the sensor? Can you all see the 1023? Can you all see 1023? Now see, as I change the voltage reading, what happens? See, it comes down, and at 0 volts, it shows 0. And as the voltage reading changes, I'll zoom into this so I can do it more. Sorry. See, as the value changes from 0 volts to 5 volts, the reading changes between 1023. And the Arduino cannot take more than 5 volts. So you can see, look at this. You'll see the current reading. This kind of current will just burn the Arduino. 5 amps. It's going to burn the Arduino. 5 amps is very high current. Okay. So it's safe up till 5 volts. There's like no current. It's just measuring. So now you'll understand how the analog pins work and the basic code for it. Okay, let's edit this a little bit. Okay, now the digital pins, you know what? A little bit of experimenting I'm doing here. Let's see. Let's see what is the digital pin 8 say now when we give it 5 volts. No, forget the amps reading on this. It depends on on the amount of current flowing through and stuff like that. So ignore whatever the amp reading says for now. Okay, see. Now a digital pin basically does something very similar to the analog pin, but it gives a reading between, like, when if it is getting power of any kind, then it's going to give you a 1. If there is no power, it's going to give you a 0. It's as simple as that. So if I increase the power just a little bit, it starts giving me a 1. Means it's getting some power. Okay, and if there's no power, it shows 0. It's as simple as that. That's what a digital pin does. So there's special kind of sensors that give power to a certain pin when there is a certain condition that's reached, and the digital pin can basically read that. Okay, that is that. 1 second. Now I'm going to stop simulation and we're going to do something more interesting. No, Dev, I'm not letting you control my screen. Sorry. Okay, we're going to leave the volt. We're going to remove this and we're going to get a voltmeter on. Voltmeter is going to be connected to pin 8. 1 second. All right. And I'm going to get rid of this wire. And I'm also going to connect an LED to it now. Okay. Now a standard practice. Now an Arduino does not give very high voltage. Okay, so it does not give very high voltage. So you can run it without a resistor. Also, you can directly connect an LED. But for safety's sake, we always connect an LED to prevent the LED from getting burnt in case of a power surge or something. So, like I said, digital pins can give an output, right? Remember I told you it can act like a virtual switch and act like the positive of a power supply. You know what? Let's do this without the LED first. Okay, so you've got the voltmeter here. I'm going to write basic code. Then this is how you do it. Now we have to get an output, right? Oops. Yeah, better. Now, if we want to connect an LED to this, we need to get an output. Okay, so we're gonna take this function called set pin number to high, bring it in. Excuse me, I want to sneeze. Right, so we're gonna select the pin number 8 because we've connected our voltmeter to pin number 8. Okay, and we're going when we select high, let's see what happens when we ask the Arduino to connect, basically give that pin high. It'll get over half an hour before that, around 5:30ish. Depends when I'm done with the stuff I want to teach, and see what happens. Okay. Let's start the program. Man. This. Okay, are you all understanding what I'm doing here basically? I'm using this output pin and we're measuring what happens when we ask the Arduino to put that pin on high using code. Yeah? If you'll have questions, just ask me or tell me if you haven't understood something or you'll think I'm not talking sense. Yeah, negative is always connected to ground. See, now the pin, remember how we could measure voltage before? Now it's giving an output. So it's an input and an output pin. It's giving an output of 5 volts. Do you look at that? Do you see that? We're not doing the quiz until I'm done explaining what I have to. See, it's giving an output of 5 volts. Now, if it's giving an power output of 5 volts, we can easily connect this to an LED and use that to turn on the LED. Yes or no? And the pin was the positive, so we know the longer side, the anode has to be connected to positive and the cathode has to be connected to negative. We connect that, ground is a negative, and in our code we have set this pin to high and we turn it on. See, the LED is on. Okay, very simple, right? Next, we need to do something to basically, okay, now let's go back to the list I had of things I wanted to try today. Just 1 second. You're following, right? Yeah, that's what we're going to do next. We're going to do blinking LED next. Give me 1 second. Me reaching for the door. Okay, so you'll have got you've got an idea basically of turning on an LED. We're using a digital pin for that. This is going to be bad. Yeah. Next, we're going to try and blink the LED. So the command set pin 8 to high turns it on. So in output we use set pin 8 to low, that turns it off. Okay, so that's basically the very simple way to code this using blocks. But now what we wanted to do is wait for 1 turn on, wait for 1 second, turn off, then okay, and okay, you know what, let's run this. What do you think will happen if I run this program? What do you guys think will happen to the LED if I run this program? Tell me in the chat. Second. Yeah. Wait, unmute. No. Okay. What did Jatin say? He said it will be on for 1 second, off for 1 second. No, okay. This is something that you all should know. Basically, in all of these programs, you're basically having the LED. Whatever you put into this in the form of blocks, it is something that runs forever. It's like a continuous loop. So on the Arduino, whatever you program, it's always going to keep running. Everything is a continuous loop. Okay, so you don't like, you know, while scratch programming, sometimes you have to mention. You can, okay, yeah. Like how in scratch programming, sometimes you have to mention like for how long it has to loop. And the Arduino, it just keeps looping forever. Okay, unless you give it certain conditions. So you're saying it will turn on for 1 second and then turn off for 1 second, and it's going to keep doing that in the loop forever. But 1 second, look at the program. It's turning on for 1 second, then it will wait for 1 second. What about then it turns off for 1 second? But this is a loop, right? So it's just going to go right back to the top and turn on again. There is no wait in the middle. So that is why when I actually, 1 second, when I run simulation, you'll see the LED will just turn on. It won't turn off because we have to add a wait after it turns off as well. Make sense? A little bit. You did? Oh, okay, Razak. I did not see that. I'm sorry. Razak, do you want to control my screen and correct the program? Let's have one of you do it. One second. Can you? No, Razak, I think. Wait. No, I'll let Jatin do it because he answered the question. Jatin, can you correct the program? Yes or no? Nope. Okay. You'll see the LED basically turns on. It does not turn off as well at all. Because the moment it turns off, no, Dev, you're not getting it. Jatin, can you like request access to control my screen? I'll grant it to you. Razak, do you want to do it? I'll let you do it. Can you like request access to control my screen? I'll give it to you fast. Yeah, Razak, I'll let you do it. Okay, Jatin. You have like 1 more minute, Razak. Else Dev, I'll let you do something else. Are you doing it, Razak? Oh, it's not happening. Wait. Let's see. I'll give you access. Razak, no. No, you have to request access to control my screen. I can't grant it to you. I was just telling you how to do it. No, not Dhruv. Razak, yeah. Okay. There, Razak, I think you can control my screen. Can you correct the program? No, you don't need it. Why are you using the if? Wait 1 second. And okay, can you start simulation now? Let it load. Yeah, that's all you have to do, Jatin. You could have done it. It's okay. We got more. I'll take care of this. Let me. One of us. Oh wow, I can actually decide who gets to control my screen. Okay, see, turns on for 1 second, waits, turns off for 1 second, waits. Okay, everyone understood basically? All right, let's move on. Wait 1 second. Not yet. Who is so honest, Vedant? Okay, next what are we going to do? We've got the LED to blink, and we've got this working. Let's just add a few more combinations to this. How about we try controlling 3 LEDs? Razak is still controlling my screen. Razak, 1 second, stop. Let me about your control. Okay. Next, what are we going to do? We are going to put in 3 LEDs. And I'm going to make one green RGB. This one green. We're going to make a traffic light. Let's make this yellow. Okay. Again, this is going to be very simple. You get 3 resistors. Connect them next to each other like that. Pin number 8. Okay. We need to move this up a little bit and use wires for this. I wanted it to look a little bit decent, so I'm going to connect this like that. We've got 8, 9 for yellow. And 10 for this. And best part is you can all use common ground, okay? So we can do the same thing. I'll show you how to do this with the breadboard next. But like right now, you can just plug it all into one ground because you're doing it in software. In real life, you would have used a breadboard for this. And if you're yeah, oh my god, what? You can do it. No, you do need 3 resistors for this. Why do you think you don't need 3 resistors? Even if, okay, okay, wait. I can do it with 1 resistor using a breadboard, but then I'll be using like 1 resistor on the ground terminal probably. So right now I'm not using a breadboard. That's why I'm not doing that. But yeah, when we use a breadboard, we'll do that. Okay. And you're right. We can do this with 1 breadboard. My bad. Oh, sorry, with 1 resistor. Breadboard. Okay. Right. No. Now in code, basically what we're going to do is turn the 8 on, turn it low, and at the same time, turn 9 high. Then wait for a second. Then turn this high and control, wait for 1 second. 8, 9, oops. You can just use this, let's see. Yeah, we will. Okay, and high is basically an equivalent of 1 and low is equivalent of 0. When the pin gets a 1, it's giving out 5 volts, and when it gets a 0, it's not giving any volts. So now this is basically a simple traffic light program. Let's start simulation and see how does it work. Oh, there's something missing. I forgot to turn off pin number 10 in the beginning. Do we need to put one? No, I want them to happen simultaneously. So the moment one switches off, the next one has to turn on, right? It's not like all 3 are going to be off for like a second. Why is this happening now? Man, I'm taking classes. Y'all can hear me, see me properly. How's my Wi-Fi messed up? Yes, it's supposed to be on 1. Wow, I'm making mistakes. Thank you, Farhan. Dev, what mistake are you going to show? Omar, we already used the 3.3 volt pin. It's like the positive of a 3.3 volt battery. Look, the program is running now, guys. Turns one off, then turns off, then turns the other one on, and so on. See that? And the code is super simple. How many of you are going to try this after the class? Wow, everyone. Send me pictures, okay? Oh, and you guys remember the video I asked you all to make, or like send me a text of how you're liking the classes, if you're liking the classes? Remember that? So only one of y'all sent it. Thank you, Aldrin, for sharing that with me. Yeah, Aldrin did it. So thank you for that. If anyone else, if y'all can, then please do it. I'll share my WhatsApp number at the end of the class again. Okay. Not only that, can all of y'all send a message to me on WhatsApp? I want to make a group for this because sending emails isn't working that well. like emails are coming in pretty late. So if you all can send me a message on my WhatsApp number, I'll put you all in a group and then we can use that basically. Adi, I'll suggest you watch the recordings. Even this class is getting recorded. So I'll share my number with you all, okay? Okay, next, what do you want to do? Let's make the same circuit on the breadboard, and like how Dave, do you want to show us how we can do the same thing with one resistor and a breadboard? Anyone willing to show this to me? I'm going to leave the parts out. Wait, what does he have to say? Okay, Dave, you can delete. Wait, Dave, don't do anything yet. Let me delete everything first. Wow. Let me delete everything first, okay? Okay, these are all the parts you get, and you know what you have to do. So start. No, the Spiro does not have an Arduino, but it has a microcontroller, a different kind of microcontroller. One second, Dev. Wait. Okay, start. Yeah, Vedant, you can email your number to me. Dev, are you doing this? Okay. So he is starting by completely pushing out the Arduino out of frame. You can press escape when you're drawing a wire and it is not what you want it to look like. No, that's okay, Arden. You can take screenshots, that'll be easier for you. If you're on a Windows PC, press the Windows key and print screen, and it'll take a screenshot. So you don't need to take pictures with the camera. Yeah. You can see what Dave is doing. Oh, I can't use my mouse. Dave, you need to be fast, okay? See, so Dave is Dave. One second, can you leave? One second. Yeah, now continue. Fast, Dave, because I don't want people getting bored. And I cannot see your chat, so I'll have to open up my phone. Stop it. Okay, Dave, you can't control. You have control. You know what? I think this is wasting a little bit of time. So how about you all do this at home and share the picture with me? And if you all share the picture, I'll let you all do something in the next class. Right now, I'm gonna have to be faster because this is taking a lot of time. Okay? For 2 minutes, I wasn't talking. Past 2 minutes, it was just Dave doing it. What do you want to do, Omar? Questioning me so much. Okay, guys, how about this? Yeah, do that. Now, basically, if you have to use a breadboard, a very common practice. Now, remember how I kept insisting, I literally got triggered when I told you all that the ground pin is not used for, is like this negative rail on the breadboard is just an indication for you all to be clear. So common practice and a good practice is basically to make sure that you're using that as like a common ground. So like if I connect the ground pin to this whole line becomes the ground of the Arduino. Yeah, that's okay. And Omar, you want to control my screen and do the circuit? I have a deal for you. Basically our deal, next time you do not spam the chat with anything irrelevant, I'll let you control it, okay? And I'll let you do something. But until then, nope. Okay, next, so do you all agree that this whole rail has become the ground of the Arduino? Yes or no? Yeah. So I'm gonna, and all the LEDs, the grounds have to be connected. And like we said, we're going to be using a common, we're going to be using one resistor. So I'm going to connect firstly all of the grounds to a separate line here. Let's do this like that. All right. And then I'm going to use a resistor to connect this to that. One second. Yeah, like that. So now through the resistor, all of the grounds are connected. Okay. Now we're going to connect the anodes. So same circuit as last time. Red one goes to pin number 8. Yellow to pin number 9. And green to pin number 10. Yes, it's connected to negative. You have code. Yeah, I have to code also. Are you guys understanding what I'm doing? And you'll be able to do this on your own, yeah? I don't think it's difficult at all. Yep. Okay, good. Now, what's the code like? Code is the same. Code remains the same. It will turn like basically, okay, one thing that we can change is we can take this to the bottom. So it's going to turn pin number 8 high, wait for 1 second, then turn 8 low and turn 9 high. This has to be 1. Then wait for 1 second and turn 9 low and turn 10 high. See. Run it. Run it, run it, run it, run it, run it. Quiz will be in like 15 minutes. I'm missing my chemistry class for this class. Great. Oh dear. Yeah, no, I'm not kidding. Okay, so see, turns 8 high, waits for 1 second, turns 8 low. Then turns 9 high, waits for 1 second, turns 9 low. Yeah, look at that. On, and so on. Yeah, got it? This should be like. Okay, I'm going to stop the code because we've understood that this is working. Okay, now what to do next? What did I have next? We're going to do switch in an Arduino. Delete this code because we don't need it. Delete all of this because we don't need it. Delete, 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 delete. Okay, next we're going to do switch in an Arduino. So here's the characteristic of a switch in Arduino. If you're asking, okay, right. So anyone getting bored so far? I'm guessing not so. Yeah, we're going to be using a push button with the Arduino. Right. So now here's a thing about basically the Arduino. When you connect a certain pin, we're going to be using analog pins for this. Now look at this, okay? Delete backspace. Yeah. Now if, I'm going to go into code and I'm just going to tell the thing to read analog pin and print the value to the serial monitor. That's it. Without anything connected, let's see what happens. Once it starts. What subscription? No, I've not got a subscription. We got lucky. Somehow the Zoom AI inspector extended our class this week. 1 second, I'm waiting for this to start. Great, this is annoying. Yeah, bad luck, I guess. See, you guys see this? The unlock pin is giving random values. Yeah. Yes or no? You'll see it's giving. You'll see it's giving random values. No, it's been 1 or 15 minutes. Yeah. So now this is like a thing with the Arduino. If there's nothing connected to an unlock pin, it just gives random values of voltage based on external disturbance, external noise in the circuit, something like that. But the moment you connect ground to analog 0, look what happens to the value. Look at that. You guys see that? It all becomes 0. Right? So now if I take a switch, right, not the block. If I take a switch and you know the switch gets connected, what way? Diagonally. Yeah. And through the switch I connected to analog 0. Now in the code, I'm just printing this value. Okay. And I start. When the switch is released, when stop. Now start. Yeah. Okay. The diagonal property, yes. Has this thing started? Yeah, why is it reading 0 then? There's something wrong. Okay, so somehow our switch is acting up. It's connecting it while it's not supposed to be connected. What a traitor this switch is. Let's use another switch then. Let's use a slide switch for now. Guys, my internet, this Tinkercad is not working today. It's tripping pretty bad. Yeah, you see it's not working. Let me reload. Guys, is everyone understanding? Cause yeah, my internet is at slow. Cause I got feedback from few parents saying that you all are not understanding. Is that the case at all? Then tell me. If you all aren't understanding, just tell me. You all want to message me privately, then tell me that, so I can explain it to you all. Nope, everyone understood. Like I want everyone to respond just so I can be sure. Okay, man. Okay, guys, I think this simulation will not work in Tinkercad all that well. Maybe we should use slide switch and try. Oh, you told that's right. No, I mean, if you all have doubts, then you all can ask me. That's all. I'm just telling you all not to like talk about random things in the chat because you can distract each other. I don't want that. Right? So for some reason this isn't working all that well. Let's try one more thing. Let's okay, we know when we connect 5 volts to the analog pin, it's going to show 1023, right? It does do that. So how about we put a switch here? No. Yeah, I think for some reason it's like the switches don't work. It's somehow causing like a connection across when it shouldn't. Okay, one thing we can be clear of if we ignore this, that the moment we press the button, it becomes 1023. So you know what, I'll re-look at this switch, I'll see what kind of a circuit we can make with it. But in the meanwhile, we've got this, right? So now we'll use a condition. Now what if we add a condition that says if, so we add a if LED, basically if input, what do you not understand, Hussein? Okay, Hussein's gonna tell us, like, okay, Hussein, tell me, what did you not understand? Oh, you're are talking about the switch ka thing? How about this right now? I'll just show the demonstration to you all, and I'll have a proper explanation for why Tinkercad is behaving this way. If I had like a physical circuit, I'm not writing anything. If I had a physical circuit, it would be very different, but Tinkercad is behaving differently. So I'll have to check on switch and on Arduino here. One second. If they have a ready circuit, let's use that. Okay, they're using a different kind of circuit. I don't want to use this right now. You know what? I'm gonna check on why does Tinkercad need this kind of a circuit with the push button? But for now, just see the demonstration, perhaps. I'll explain it to you all, but like something I'm entirely not clear about myself. Okay, but for now, just ignore the switch part, okay? Other things are fine. Look at the code. You know what? Sorry guys, I'm not using this as well. What is happening? Right. I'm gonna stick with this stuff. Right, but I'm okay. So basically, I'm going to program this thing to say that when the button is pressed, it turns on an LED. And again, I need to use a resistor because I told you I always use a resistor. Okay. Yeah, I did not test the whole button thing because I was busy, but I think I should have because this is not working out. So just use an if math input analog. I'll explain what I'm doing in the code in the next class. Right now, I just want to demonstrate it to you all. You know what? Let's put this here. Okay. Oh, no. Yeah, many didn't come today. Need to figure out why. So basically, you see when I press the button, the LED turns on. So you can add logic like that to your circuits in the Arduino. You know what, guys? Let's do the quiz today. And I'm ending a little bit early because basically the whole switch thing is not working, and I'm a bit put off about that. So I will take care of that. Now let me play live. Yeah, Ishan did not come. That's the link in the chat. Oops, I sent it to Razak. I meant to send it to one. Okay, you can join the quiz. That's my number. Send me a WhatsApp message here. Can't stay. Oh yeah, we were gonna do funny names this time. Man, I'm not so much soon on the mood. But you guys wanna do that? Yeah, Dave, I remember. Yeah. You guys wanna do that? Not use your real names, use some funny name, something different. Yeah, I'll reload then. Let's see. Excuse me. Camel, right? Camels are coming to the quiz now. Voldemort has a nose. Does he? How many people are in? 3, 7. Pikachu. I hope he wins. Arduino boy, don't let me down. Okay, anyone coming in or should I start? Isaac Newton's relative, Scooby-Doo, Aldrin's army. Cool. Couch potato. Hey, that's me. Who else? Best of the memes. I'm guessing that's Omar. Okay, can I start the quiz? You want me to remove camel? Why? Where's camel? Camel. Sure. Okay, ready? 3, 2, 1. Arduino boy straight in the lead. That's quite a statement he's making there. Oh wow, I found my bench stats. Okay, so Pikachu's in the lead. Wow. I think you took me seriously when I said don't lose with that name. Razak's in the lead with his real name. Then there's Arduino boy. Then there's Pikachu. And then there's Couch Potato. Woof Woof Sniper, whatever that is. Arduino boy taking over again. You're making a lot of mistake. Only 57% accuracy. The quiz is really easy, guys. I was in no mood to make the quiz today, so I just put in some very simple questions. Okay, finish this fast. So Arduino boy gets in first place. Isaac Newton's relative. Wow, you're ashamed to your family. Comes in second. What, Avinash? You don't have manners. You're doing the quiz so early, so bad. I'll tell your parents. Yeah, I know. Tell them. Sure, they're disappointed in me. It's okay. It is what it is. So Arduino, Voldemort comes in second with a nose. He's my favorite. Yes. Then Isaac Newton's relative and whatever the name, funny name that was, and Razak's first. And can I ask who was Arduino boy? That's right. That's nice. That is your survey link, guys. You can do the survey, then you're free to leave. It's quite a slow class today, according to me. Like we could have done more. Okay.